Okay, this is my filter and peak detector circuit. We have a RC circuit here and two buffers working as differential amplifiers with unity gain, and our peak detectors here. So there's one peak detector right here. The diode goes up to this resistor and capacitor to discharge down to ground. And then the other peak detector I had to place over here. Here's the diode, capacitor, resistor, discharging to ground. So our low frequency information is here, and our high frequency peak detector information is tapped off here. Now I designed my filter to work with a cutoff frequency of 200 hertz. So we should expect at 200 hertz for both of the levels to be even. So I'm just going to play 200 hertz sine wave, and you see here the high frequency information is this blue audio wave, and the low frequency information is this orange audio wave. They're a little bit off right now. And after doing some finagling with the frequency off screen, I found that we've more so got a cutoff frequency of around 300 hertz, which I deem is okay. If you look very, very closely at the waveform, you can see the peaks and their tiny little decays. Now, since this is such a high frequency and our time constant in our peak detectors is around 400 milliseconds, we're going to see this work almost as if it's a rectifier. So I'm going to stop playing this audio source, and you can see it decay. So let's do it again. Turn it on, and then it decays. Now, for an example, I'm going to run my audio wave, and I'm going to increase the time base. You can already see the peaks kind of going a little bit crazy here. Let's see here, 1 microsecond per division. Is that a little too fast? How about a millisecond? Okay, so you kind of see them bouncing up and down a little bit on these bias points, which is good. Let's remove the low frequency information and just measure the high frequency information for reference. So I'm going to tap this. I'm going to read the audio input like such. So we're reading the audio information here on our scope through our orange channel, and then we're getting the high frequency peak detector. You can see here, as the density of the audio wave increases, this tends to increase as well with it, and that's because our filter allows higher frequency information to pass through it. Now, if we do the same for our low frequency information, here's our low frequency peak detector. Now this blue wave should be responding. Hold on. There we go. See? As the audio signal gets wider, you'll see this increase. You see how when there's very small waves, it's very narrow, it decreases, and then as it gets wider, it pops up a little bit. It jumps between a volt and about half a volt.